This video tutorial will cover an example of an assembly drawing. We will work through an exam equivalent question from start to finish and give you an idea of the process to be followed in order to complete the question. We'll start by looking at the information that's given and what is required of us. So we are told that we've been given multiple orthographic views of components that are used in an assembly of a standard butterfly valve. We've then also been given a sectional line which has been taken through the center of the valve housing. So we'll have a look out for the valve housing in the parts drawings, and that there is a section line AA. This is giving us an idea that the valve housing is the main component or our base component of our assembly, so we'll start with that component and then build everything else around it. We're also given an exploded view of the butterfly valve and an associated parts list, so this will give us a good idea in terms of what components go where and how we need to draw them. The third part is an isometric view of the valve with a quarter of the valve being sectioned. So we'll actually have some idea of what the drawing looks like on the inside. This isn't something that is often given, but when given it does help to draw the side view that we need to draw a lot more easily. We are required to use the section line AA to draw an assembled sectioned front view of the butterfly valve. The sizes of the washers need to be taken from the attached formula sheet. So we'll use our tables to determine the washer sizes, but the main deliverable here is an assembled sectioned front view through section line AA. So the best place to start with these drawings is to have a look at the provided exploded view, and we can see from the exploded view general layout of where these parts would fit in the assembly. So if we have a look from right to left in this case, we have some base plate, we've got a bushing over here, we've got part number 2, which is a stub shaft. The bushing fits over the stub shaft and the bushing fit against our base plate over here, which is part number 10, which is called a cover plate. We then have 2 washers over here, so these washers would fit over those holes, and this base plate or this cover plate would screw into the bottom of our valve housing. Then we have our valve housing, we have our valve, so the valve of course will fit inside the valve housing. It's just been pulled out to illustrate what it would look like in the assembly. So that would fit inside our valve housing. We then have, you can see there's a square hole there as well as a square section on the shaft number 3, which is a drive shaft. So the shaft number 3 would fit into that square section, which will obviously then sit in this section of our valve housing. Our bush will fit over the shaft, and we then have another cover plate at the top which will fit onto this section of our housing over here. We then have our handle, which will fit onto our bush, onto our drive shaft. We can also then see over here where they've sectioned part of, they've taken a quarter section of our housing, so we can see the components inside. We have our housing, and inside of our housing we can see that our valve fits inside here. There are our 2 bushes, and our handle fits on top, and here are our 2 our Bosch plate on top and our cover plate on the bottom. We'll be using this information to determine where each component goes in our drawing, and then we'll have a look next at the orthographic views to determine exactly what needs to be drawn. Okay, so there are 2 pages of orthographic drawings. On the first page we have only our housing represented. we can see a front, a side, and a top view. The important one for us now is the front view, because that's the one we'll have to draw. And we can also note that section line AA is taken over here on your top view, and that's the section line that will need to be brought through to the assembly. So we're going to be cutting it along this line, removing everything in front of that line, and drawing only what we would see at the back. So we're essentially cutting it through the center line of that component. And here are the dimensions on the front view that we're going to need to be drawing in our fully assembled drawing. Okay, the second page of orthographic drawings contains all the remaining components. So we have our bush for our drive shaft over here. Important is the front view here. Remember that the bush will be sectioned, so we'll essentially be seeing the outline as well as the edges at the top and the bottom. We then have the bush for the stub shaft, which is the same. When we draw it in our front view, we'll only see this rectangle as well as these two lines over here, because it's being cut along the middle. So you're seeing that edge there and that edge there, as well as that face over there, where you have sectioning lines over the areas where that get cut. We then have our cover plate. Okay, so it's just going to be this rectangle rotated through 90 degrees, and you should also see the representation of these holes. We then have a dowel. Okay, the dowel fits, we can see that our dowel is a 4mm outer diameter. It'll fit into this hole over here on our handle, which is also a 4mm diameter hole. 2mm radius, which gives us a 4mm diameter. We then have our stub shaft, okay, and it's telling us that this is the square end that's being represented. So we need both the front view and the top view in this case, because we need to know that this is square and not round. So this section is round, that section is square. And that's because it fits into the square section at the bottom of the valve. Our drive shaft, we're going to be seeing this side of it, and we know that this is square and it fits into the square section on the top of our valve. The Bosch plate, this simply fits onto the top of the housing, and we'll be seeing this view rotated through 90 degrees. Then, in terms of our handle, our final component, we'll be drawing this part of it here, and that'll fit onto the top of our drive shaft and above our Bosch plate in the top of the housing, with the dowel going through both the both the handle as well as that 4mm hole in the drive shaft to locate it rotationally. Now that we've had a look at all the components, we'll decide what to draw and what order to draw it in. So the first thing we'll draw is we'll draw our housing. We'll represent this view here, starting with all the outlines and then figuring out what goes inside. Then following the housing, we'll start to draw in the rest of the components. So it's probably easiest to go down first. So once we've drawn the housing, we'll draw the cover plate at the bottom as well as the bush and the shaft there. We'll draw in the valve, and then we'll work our way to the components at the top, but we'll build it up piece by piece. Okay, so in order to start drawing the assembly drawing, we're going to start with the housing, which is our base component that all other components are going to be built around. Now, with our housing, the prominent features are these circular features here and here. So the first thing that we do is we draw in this center line from which to take measurements, as well as a base plane to measure from. So we're going to start by drawing from the bottom up, and the first thing we need to do is locate the positions of the centers of this circle and these circles here. So in order to determine what this height is, we need to look at the side view. If we have a look at the side view here, we can see our given dimensions. The total height of this component is 110 millimeters, and the distance from the top to the center of our circles is 65 millimeters. Okay, so we take 110, subtract 65, and we get a height of 45. So what we then do is, from our baseline on our center line, we measure up 45 and we draw in that line. Then, to get the center of these two circles, we're going to take 45 again, because that's our dimension. We see that the distance from the center line to the center of the circle is 45 millimeters. So we'll measure off and mark 45, and we'll measure off and mark 45. We can then draw those in as light construction lines. And these small circles, at least, we can draw with our circle templates. So we have a 10 diameter and we have a 14 diameter. So we'll start with a 14 diameter over here. We just position our circle template. And here I'll just draw in on the outer circle a half circle. And for the inner circle, which is 10, we'll complete the full circle. And we'll repeat the process on the left hand side. A 14 diameter followed by a 10 diameter. Then, just to get an idea, we're going to project across these horizontals. And we'll fill in the details, and we'll fill in these details once we've drawn the other two circles. So we have an inner diameter of 50 and an outer diameter of 70. Unfortunately, we don't have a big enough circle template for that, so we're going to have to use our compasses. So what we need to do is we need to measure off a 25 and a 35 radius. So we'll start with the 25. And we'll just draw that in. And we'll then draw in the 35 millimeter radius circle. We will be erasing part of this just now because it is going to be sectioned, but for now we'll just keep in these details. Okay, and then we can draw in the horizontals that we put construction lines for earlier. Next, we'll fill in the bottom section over here. We can see that the distance from the center line to the edge is 15 millimeters. So we'll draw in that baseline 15 millimeters on either side. And we know that the distance from the center line of the circle to the base is 45 millimeters. So we'll start by just measuring our 15 millimeters from our center line. And we'll then just project that down onto the base, just with light construction lines. Then we can draw in our baseline. As well as these vertical lines. The next detail to add on that bottom section would be the holes that have been created. So we'll just indicate their position. The center of those holes is 11.5 millimeters from our center line, and they are 4 millimeter holes. So I'm just going to do the basic detail for now. We'll fill in the threads and all the rest afterwards. So from the center line we have 11.5, and from our center line we have 11.5. We'll just project those center lines up, and then those are 4 millimeter holes, so we'll just take 2 millimeters on either side of our center line. And again, just project up. If we have a look on our drawing, it says that the depth of those holes is 10 millimeters. Remember that these holes are visible purely because the component has been sectioned along the section line AA. Okay, so there our holes have been included on that drawing. Now, an important thing to note is that we are sectioning through that plane, so we are cutting away this section of material. So we can see these holes, and we'll also be able to see this hole over here. And the diameter of that hole is given on our side view, and it is 17.5 and 37.5, so it's 20 millimeters the difference between, wait, no, it's 32 and 17. So that difference is 15 millimeters. So we know that that's 15. So I will erase the center here because there's a hole through there, and we then mark off 15 millimeters from either side of that center line. Well, 7.5 from either side, 15 total. And that hole does go through the entire component, so we will just project all the way up to the top. And we'll erase over here as well. You also won't see that as an edge. Okay, so with that, the bottom of that component is complete. We'll now move to drawing the top. Moving on to the top of the component, we know that 65 millimeters is the distance from the center line to the top, so we'll just put a construction line at the top to create a framework within which to work. So we'll take a 65 millimeter measurement from our center line, and we'll then draw in a construction line there. Okay, then we can draw this flange plate at the top here. That is a total of 10 millimeters deep and a 70 millimeter diameter. So from our center line, we'll have 35 millimeters to either side. Just drawing construction lines for those boundaries. Okay, so we can now continue to draw the top flange, which was 10 millimeters thick. So if we just draw the construction lines for the outer edges, and we can then from that top line measure off 10 millimeters, and then we can again draw a construction line there. Now that we've got that detail, we can fill in the majority of it. And now we'll look at completing this section of the drawing. So we can, because it's sectioned, these hidden detail lines will be visible edges, and we know that this width of this outer section here is 20 millimeters total, because it's 10 millimeters from the center line, and the width of this inside dimension is 15 millimeters as shown over here on our top view. So we'll draw in 20 and 10 millimeter construction lines, 20 and 15 millimeter construction lines about our center. That's the 20, and then we'll do the 15. The 15 we can draw straight up. It's the same lines from the bottom. And then the 10 we can draw in just to that plate. Okay, so we've almost completed the housing. We just have this web over here that needs to be added in, which is 25 millimeters from our center line. So we're going to go from our center line and we're going to measure off 25 on both sides. And then we can just draw in that web here. Okay, we've then completed our flange. When sectioning this component, we'll section all of this region here. This doesn't get sectioned because it's a web. Now that we have the housing completed, we're going to look at building the rest of the components around the housing. So again, we'll start with the components at the bottom. We're going to look at the bottom plate, which is the cover plate. We'll look at the cover plate, we'll look at the bushing and the shaft at the bottom. So the cover plate we know will just fit directly onto the bottom here, the bushing will fit into here, and our shaft will fit into the bushing and protrude over there. So we'll start with the cover plates, and if we look at our orthographics here, we have our cover plates. This is the important view. We will have these holes indicated, so it's 5 millimeters thick and it's 5 millimeters thick and it's 30 millimeters long, which matches up with our base over here. So all we need to do is project 5 millimeters down, have our construction line along there. We can then fill in the sides of the cover plate and then the base. For our holes, we can project from the center lines of the holes on the above component because it's the same position. And then we can check our hole diameter is 4 millimeters, which was the same as the hole diameter on the housing. So again, we can just project down for our holes. And that will be the completed cover plate. The next thing to draw in will be the bush, and that's your bush for your stub shaft, which is 20 millimeters long, and then it's got a 12 millimeter inner diameter and a 15 millimeter outer diameter. The 15 millimeter outer diameter will be the same as the 15 millimeter diameter of the housing, so we just need to indicate the 20 millimeter length just going to redraw in the center line here, and we can measure out our 12 millimeter outer diameter, so we'll have 6 millimeters on either side of the center line. Okay, and that is the completed bushing. The next thing that we can draw in is our stub shaft, which is this over here. The 12mm diameter is already indicated over here. It's 20mm high, so we've already got that section, so we just need to put the 8x8 square end on, where that goes to a 30mm length. So we can measure from the bottom 30mm. Again, a light construction line. And then from the center line, we know it is an 8x8 square end, so we'll have 4mm on either end of that center line. And we can then draw in that detail. So now we have our cover plate, our housing, our bush for our stub shaft, as well as our stub shaft. The next component to draw in would be our valve, but we actually don't need to add in any additional detail to indicate the valve. The valve again will also be sectioned along its center here, so all that you're essentially going to see is the round section of the valve and these as solid lines where your shaft will fit into, which we can see is already represented over here. So the next thing that we can then indicate is the drive shaft as well as the bush and the like for that component. However, if we go back to our exploded view, we can see that on top of this housing we're going to have our Bosch plates over here, and the bush as well as the shaft will extrude through the housing as well as through the Bosch plate, where this flat edge or the end of the cylindrical section of our shaft will be flush with the Bosch plate. So it's going to be easiest to draw in the Bosch plate first, and then we'll get an indication of where to position our shaft and bush. So if we have a look at the Bosch plate, we're going to be drawing it sectioned through this line over here. So we'll see a rectangle rotated through 90 degrees relative to this, which has a 70mm diameter, 35mm radius, and a 5mm thickness. So we'll draw in that outline and then the whole detail. If we just check, the top of our housing is also 70mm, so we can just project straight up off that, and we need a 5mm construction line to project onto. Then again, the holes in the Bosch plate are exactly the same 6mm diameters as the holes in the housing, as well as the center hole. So we can just erase those sections there. This will be the center 15mm hole in the Bosch plate, that hole over there, and then the other two holes will be these two. They are full through thickness holes, so we'll just see them as rectangles in our section front view. Okay, and that will be the complete Bosch plate. And now we can draw in the drive shaft over here, as well as the bush that the drive shaft connects to. However, if we do check on our Bosch plate here, this diameter is 12 millimeters. So it's actually slightly smaller than the 15 millimeter hole in our housing. So I'll just make that adjustment quickly. So across the center line it's 12 millimeters. Okay, so the next thing to draw in will be the bush for the drive shaft, which is a total 40 millimeter length, and it is 15 outer diameter and 12 inner diameter. Being 15 outer diameter, it won't fit through this section, so it's safe to assume that your bush will butt up against that edge. So we'll take 40 millimeters down from that edge, and that'll be the bottom of our bush. And the top of our bush will lie butting up against the Bosch plate. The bush has a 12 millimeter inner diameter, which is the same as this hole, so we can just project straight down again. Projecting from similar edges saves a lot of time, so you don't have to measure all the time. So there we have our bush. Then we need to draw in our drive shaft. We can see at the bottom it's the same as the stub shaft, it just has an 8x8 square, and it has a 12 millimeter cylindrical section, which will fit nicely into the inside of our bush. And we can see that this middle section here is 45 millimeters long. We can see it's 55 here minus this 10 for the square end. And we can also look on here, this distance is 40 and that's 5, so our bush is going to sit flush with the top of our Bosch plate, or the shaft rather is going to sit flush with the top of our Bosch plate and with the bottom of our bush. And we then have the 8x8 square section protruding from the bottom. We actually don't need to measure that, we can just project straight up from the other square end. And then again it protrudes 10 millimeters from the cylindrical section of the shaft. Then the last detail on the drive shaft is this top section, which is a square 8x8 square, the same as the bottom, but it has that 4 millimeter hole in it. So from the top here, we just need to construct our 8x8 square, which again we didn't need to measure, we could have just projected. And that will also be 10 millimeters. And then the last detail is to include the 4mm hole, which is a 60mm distance from the bottom of that drive shaft. So we'll measure up 60 from here. And we'll put in the center line for that hole. And then, oh, that's skew. Put in the center line for that hole, and that hole is 4mm in diameter. So we'll use our circle template. And we'll put in the hole over there. And the last component that we need to now draw is the handle, which fits on the top of the assembly with this square end with the round hole and that section there fitting together, and then the dowel pin fitting through the hole on the handle, and the drive shaft connecting those two components and holding them in place. So we'll start with this bottom section, and then we'll build around the spokes and the circular handle section. This bottom section is 10mm high, and then the height or the width isn't directly given, but it'll be constructed from the 45-degree angle that the spokes come out at. And we can see that at this 45-degree angle, the vertices of that rectangular section are coincident. So we can get the width from those construction lines. So we first start with a construction line of 10mm to indicate the height, which again, we can just project from an existing component that we know is already at that height, and we then have 45-degree projections Now, where these 45-degree projections intersect with the height is the width of that component. Then we are told as well that the height of the center line of the top of the handle is 27.5mm from its base. So we can project, or we can measure off 27.5, and we can just make a construction line across there. Where that intersects with our 45-degree lines, it is the center line for the circular parts of our handle. Being sectioned through this plane over here, we will see a cut through that section there, and those areas will be sectioned. It is a 5 radius, so it'll be a 10 diameter circle that we'll see. We can draw in those circles. then we can draw in our spokes, which are 5 millimeters wide. So we'll have 5 millimeters about our center here. Also at 45 degrees. And then we'll draw in the back of the handle, which you will see. And there, all of our components are fully represented, so the final task is to section the drawing. We will be sectioning this component, this component, this component. We don't section our shafts, we don't section our webs, and we won't section this part here because it's the back of that handle, and we don't section the spokes either. Remember that when sectioning adjacent components, we want to draw our section lines at the opposing 45-degree angles, and also we want to change the spacing when there's more than one adjacent component. So we have this bushing, the housing, and our cover plate, which are all adjacent to each other. So we need to swap out our 45-degree angles and also change our spacing. And once the sectioning has been completed, the drawing will look as follows. The only details remaining will be the washers, the sizes of which will be read from the relevant tables, and those will then be drawn in. In this case, the bolts or screws have not been specified, so you would not be required to draw those. Just a reminder that webs and shafts, as well as the spokes on this wheel, do not get sectioned as a rule. In terms of the way questions like this will be marked, I am looking for 1, the correct positioning of each component, 2, the correct drawing and representation of each component, 3, the correct sectioning of each component, and lastly, a mark will be ascribed for neatness. This particular drawing, all the components are in the correct place, all the components have been correctly drawn, they've all been correctly sectioned. However, it isn't as neat as it could be, so it would not get full marks. First priority is to make sure that all of your components are drawn correctly, to the correct proportions, to the correct dimensions. Second priority is to ensure that they're all indicated in the correct place. Remember, it's more important to draw a component completely than have parts of the component represented. So rather complete one component entirely than present 2 half-drawn components. And then with the sectioning, keep it as neat as possible and remember the components that should and should not be sectioned.